Newton's third law is all about two objects and how they interact with each other and exert forces on each other. Newton said that forces always come in pairs, and whenever one object exerts a force on a second object, the second object will also exert a force on the first object. And more importantly than that, perhaps, those forces will be equal in magnitude and opposite in direction. And that is basically our starting point for Newton's third law. And here is a statement of Newton's third law, and it says this: if object A exerts a force on object B, then object B will exert an equal and opposite force on object A. And this is always true. Forces always come in pairs. So wherever you have two objects, if they're in contact or if they're not in contact, they will always exert a force on each other. And those forces will not only be opposite, they will be the same. They'll be equal in magnitude. And obviously this happens all over the place. So let's have a think of a few examples of that. And the first one, I guess, might be swimming. So here's some water, and we have a person in the water swimming, legs going up and down, and they're doing their front crawl or whatever. And at this particular point here, this hand is pushing back against the water in this direction. They're pushing backwards on the water. So the question is raised, if they're pushing back on the water, why are they going forwards? Well, we can refer back to Newton's third law to try and explain this phenomenon. If the person is object A and the water is object B, then Newton says that if object A, i.e. the person, exerts a force on object B, i.e. the water, then object B must exert an equal and opposite force on object A, the person. So what's actually happening here is the water is pushing back, and the water is pushing on the person with a forwards force that propels the person forwards. So it's actually the reaction force, if you like, of the water pushing back on the action of the person, which causes the person to go forwards. You're actually pushing the water backwards, and the water is pushing you forwards. Similar example to, well, let's take the example of a rocket, which is a classic example of Newton's third law. Here's a rocket, and what's happening with the rocket is that the rocket is expelling the exhaust fumes and the burnt fuel out of the back of the rocket. So the rocket is effectively applying a force to the fuel when it's being burned in the downward direction, pushing the fuel downwards, pushing the exhaust gases downwards out of the rocket. That's object B. The rocket is object A. So rocket A exerts a force on fuel B, and therefore, according to Newton's third law, the fuel, object B, will exert an equal and opposite force on object A, the rocket, in the upwards direction, and the rocket will move upwards. So we have this action and reaction again, which is a sort of simple form of explanation of Newton's third law. Every action has an equal and opposite reaction, but it's more useful, I think, to describe it in terms of object A and object B and them applying equal and opposite forces on each other. Here's another one, and this is slightly more counterintuitive perhaps. Here we have the Earth, and here we have a book. And in this case, the book has a weight, and I'm going to call the book object A, and I'm going to call the Earth object B. And the Earth is pulling on the book with a force equal to its weight. That means that the book must also be pulling on the Earth, and the book is pulling on the Earth with a force equal in magnitude and opposite in direction. So as the Earth pulls the book pulls the Earth, and those forces are equal and opposite. Object A is the book exerting a force on object B, and object B is the Earth exerting a force on object A, the book. And again, those forces are equal and opposite. So I picked that example because it's slightly more counterintuitive, and it's an example of a non-contact force, the gravitational force, being applied to two different objects, object A and object B. So this happens everywhere, all over the place. let's pick another example. Let's do example number 4. Let's have a car. So we've got a car here. Can't draw cars very well, but I'm just going to try anyway. There we are, there's your car. And this is the driving wheel here, and the driving wheel is pushing with a frictional force against the ground, and it's pushing the ground in that direction as it spins this way. The car's going to head off in this direction. The car pushes the road to the left, if you like, with a frictional force F, which means, according to Newton's third law, that the road pushes back on the car in the opposite direction with an equal force F, propelling the car forward. This force here acts on the road from the car. We could call the car object A and the road object B. It acts on object B from object A, and this force here acts on the car from the road. So there are always two objects involved, the same two objects, object A and object B, and object A exerts a force on object B, and therefore object B will exert an equal and opposite force on object A. The other thing to say is that force might be unbalanced. So if you bring Newton's second law into it, if this force F pushing forward on the car is unbalanced, that will obviously cause the car to accelerate. So Newton's third law pairs can, if you take one of the objects involved, can cause an acceleration, a change of momentum, in order to change the motion of that car. And that's Newton's third law.